So thanks everybody for joining us. Today I want to talk about whether or not it's time to modernize your database architecture inside of AWS. So really what's happened over the past 3 years or so is the evolution of data architectures has changed quite a lot, as has customer and user requirements for what they're looking for out of their data-powered applications. Of course, that's driven because user behaviors changed all over the place. So what I'm first going to talk about is the requirements that we're seeing for these modern applications and how that's starting to affect how people are planning to build them. So number one is we discovered that customers are really trying to deliver really killer user experiences for their customers. Now the challenge here has been that your users themselves changed all their behavior. Right? They went indoors, they went outside in the parking lot, they stopped coming into the retail outlet, and so that behavior really created a conundrum for enterprises to figure out, all right, what are we going to do to continuously address their needs? The second thing is, on your developer side, is how do we deliver these solutions as efficiently as possible? Right? If you're moved into the cloud, that's great. Right? But then you've got so many services to deal with inside of AWS that creates a lot of complexity. Perhaps you're using multiple data stores inside of AWS. That's also creating a lot of complexity, but you want to create an environment for your development team to build things as fast as possible. And finally, you need to support where these users are and deploy everything as efficiently as possible. Now, the challenges when I talk to customers are, they really boil down to these 4 particular items. Number one is they find their legacy systems are really, really rigid, and they can't adapt or evolve them as quickly as they want. Then they also recognize that if I've got a lot of requirements that are driving a lot of consumption on my site, that performance of the site is deteriorating. And because of that, they have these performance challenges. And that also leads to scalability issues. And ultimately, when they're deploying these things in the cloud, they're finding that there's a little bit of sticker shock with how much cloud resources you're consuming there. So what we see is, our customers like ours, these guys, right? You may not recognize that, my customers are kind of living here, but 2 out of 3 credit cards in your pocket are being managed by FICO, the fraud detection program. Carnival, if you've ever been on a cruise, either before pandemic or even just as it was starting, they have a medallion that you wear that is like your cabin key. It also keeps track of what you spend. It also keeps track of what your kids like to eat, or what you just ordered in the bar in the casino will follow you all the way to the pool. Right? So they deliver this great user experience based on the information that they're figuring out about what you're doing on board. And they're doing that through a whole bunch of IoT sensors they've deployed all over the ship, 15,000 of them. So, handling hundreds of millions of operations a day. Everybody uses LinkedIn. Your LinkedIn feed and that caching service that's delivering your feed is powered by Couchbase. Guaranteed you didn't know that. Okay, and finally, Staples is managing their worldwide inventory using Couchbase as well. So you can see that all of these organizations, and this is teeny sample. I'll keep kicking off more and more customers as we go. But all of these guys have found that they needed the high degrees of performance and in-memory based architecture to deliver information as quickly as possible. Deliver a feed like this for LinkedIn. And then they've also found that there's trouble spots that they've run into. And this is really common, and this is what you're starting to see across the board here at this show, is what's happening when you build an application, you've got your functional requirements that you've knocked out, you've got a database and the infrastructure that's living underneath it. Now, where are you going to find the bottlenecks here? So the bottlenecks really start to occur when you start to apply a 10-year-old principle of database development. Right, the polyglot persistent architecture, where you're supposed to use each database for exactly what it's built for. Transactions for a relational system. You might use a Redis or a memory-powered database for concurrency and caching. You might use a NoSQL database for account profile flexibility. But then you want things like search. Maybe you have mobility issues. All of these things are compounding, these requirements are compounding the complexity of your underlying architecture. Well, you know what? Like I said, this design is 10 years old. It's still state of the art. And there's and you'll see that if you're able to, the issues with all of this is, you're dealing in all kinds of interface issues. You're dealing in all kinds of different data integration problems, keeping everything synchronized. You've got massive amounts of copies or duplication of your data sets, right? Again, creating more complexity than you really need to manage. Now, if you look at a modern architecture, what if all of these things actually happen to have all of those same features under the same design? Under the same underlying high availability model, distributed computing model, clustering model that has a cache, a key value, JSON all at the same time. Well, you know what you get out of this is something that's really, really fast. This memory-based design makes sure that all of your operations, even if they're replicating across data centers or across regions, is really, really fast. You enjoy the flexibility of not only JSON, which is great, right? JSON allows you to change your data model, add fields to your data structures on the fly. The application developer controls all that. You don't have to go ask for permission from your DBA to change the schema and then plan a redeployment. That takes months. So the developer controls kind of their own destiny in this flexibility with a JSON-based design underneath this. But then you've got all of these multi-model services that feed features to your application. So if you need search, it's there. If you need that high-performance caching, it's there. If you need operational analytics or data streaming and eventing, it's all built in. So you get the flexibility there, and then the kicker here is every one of your developers knows SQL, right? So you don't have to learn a brand new query language. You know SQL directly. You expect things out of what a database is supposed to do, like support dynamic schema, or support ACID transactions, or have user-defined functions. All of those things are built into this Couchbase architecture. SQL++, of course, is SQL for JSON. We wrote the book on that. We're the reference implementation of SQL++. And finally, because it's really fast, and it uses resource really efficiently, it becomes really affordable. And it actually helps customers drive down their cost of ownership really dramatically. In fact, when I asked all my customers, I surveyed them, and I said, what is it that how much have you saved after you deployed Couchbase? 57% of my customers responded and they said they saved more than half of their infrastructure costs after they deployed this. So they're doing something right here in terms of being able to manage that cloud infrastructure, being able to utilize your resources as efficiently as possible. So here's the funny part. AWS makes this problem, perpetuates this problem still, because they want you to use all of their data services, RDS, DocumentDB, DynamoDB, Elasticache, Elasticsearch, all in your one design. Right? This is an architecture of a retail kind of application. But here's the punchline. You could do all of that, see all the databases over there? You could do all of that with one database. It's got all of these core capabilities built in. And then I've got one more. I've got mobility built in also. So if you want to deploy this application on your mobile device, if you want to embed it in an IoT device and gather data there, just like the Carnival Cruise example is doing, you can do that. So, and it'll synchronize data back and forth to these devices, but it'll also synchronize data among your devices, even if there's no internet connection, right? Perhaps you have a Bluetooth connection, amongst a tablet and a phone, right? That will synchronize data amongst itself, and then when the internet connection gets restored, it syncs it back up to the server. Really, really handy because, well, let's see, when you're in situations like this, and your internet service is terrible, and you still have to have an application that's available, right? It doesn't happen. But in our case, it does. So here's overall what we're seeing is, these overall integrated capabilities. The net effect for the customers is, one, you can speed up your delivery cycles. The reason being is your data architecture is less complex, right? You're only dealing in one database. When you're building it for high availability, you're only deploying 3 copies of that data, right? If you're building it for distributed environments, you're only partitioning and deploying that data in whatever regions you want it to deploy in. So it's much, much simpler. Right? If you build a simpler application, your quality goes up, right? Because you haven't stuck in all kinds of integration complexities. So you get less duplication, a lot less data sprawl. It's way easier to scale. You spend a whole lot less time on maintenance when you're building the thing because it's easy to debug. And of course, I said it's SQL that's underneath the thing. You end up lowering your operational costs, you end up lowering your infrastructure costs. So these are the ways that we're seeing our customers go through and handle situations like this. Now what I'm going to do for the last couple of minutes of this, I've got many more narrative on this idea, but I want to hit on the customers that I baked into here. So the next one I want to touch on is, let's look at, your favorite pizza delivery place, right? So you've been ordering pizza about at 11 o'clock every day because the World Cup is on. And of course I'm keeping you from the kickoff right now, so I appreciate your attendance. So Domino's is using Couchbase to analyze their point of sale information live while it's happening. So while the World Cup is going on, let's say on the East Coast where it's lunchtime, while the World Cup is going on, they're tracking all the orders as to what's happening. Now when the match goes into overtime, they can actually create a brand new a set of offers to everybody who's ordered, like here's a new 2-liter Pepsi, or buy more chicken wings, and they can place that order as the match goes into overtime, and by the time you're doing the shootout, you've got your second order there right on the spot. That's the kind of stuff that that Domino's is dealing with. The next one is all of this mobility. I've got all kinds of really cool examples of deploying data to mobile devices, because this is really probably one of the biggest growing areas of our business. So you can do field service, you can do offline first applications, you can do mobile clinics. I've got a customer who does pop-up medical clinics, like for vaccinations in remote places. And the way I do that is I've got an embeddable database that goes along with that Couchbase Capella server environment. So the mobile database allows us to synchronize that data wherever it needs to go. So you can embed it wherever you want. You get sub-millisecond response time. It's really great. But let's look at who's doing this. Emirates Airlines. Emirates has automated the pre-flight checklist of the pre-departure checklist that's dealing with everybody who's boarding the aircraft, everybody who's taking care of the aircraft, cleaning it, getting it ready for stocking it with food, the pilot's checklist of making sure it's safe to take off, and that synchronizes amongst the pilots, the onboard crew, the boarding the boarding crew, and the maintenance crew. Now the funny part is we all know your internet connectivity is terrible at the gate, right? So this internet connectivity, the pilots wouldn't touch the application if it wasn't always working for them. If it 404'd on them, they'd freak out. So what this does is it'll synchronize back to usually the maintenance guy goes back to the hangar, internet connection is restored, and all the data syncs up as it's supposed to. The flight takes off on time, it lands 10 minutes early, and allows Emirates to deliver this really killer user experience for them. So this eTech log is the application, right? Gives them 100% uptime, right? Optimizes that process as I just mentioned. Great confidence, high degree of adoption here. So what you end up getting when you're dealing in edge-oriented devices is the speed of super low latency while everything's operating. It's very reliable, and it maintains the privacy, the user account privacy of every consumer or every user. So as I wind this down, Arthrex is a customer I just announced earlier this week, right? They're a medical device company. You know what they're doing? They've embedded my database in the surgical equipment that's inside the operating room. So, and then they're collecting data on how well the operation went, and then applying that to the post-operative healing process for their customers. So the surgeons have better data about how to take care of the patients post-operatively. So our last little bit here is, let's imagine that Carnival cruise kind of impact. What does it mean to them if they're able to deploy this really killer user experience? Remember, I said, Carnival, they give you a little medallion, it tracks you all over the ship, and what happens if, let's say, the passengers on the ship each spend $100 more on a voyage, okay? Just the voyage. So 3,000 passengers times $100 times 30 ships in the fleet times 40 excursions or voyages a year, you're looking at $360 million in additional revenue because they're able to serve customers better. They added a bottle of wine to a dinner. They booked another excursion. They bought a gift right from the gift shop. So all of that adds up. And then what if they had so much fun that 15% of them rebooked at the discount rate of $900 for next year? Right, that's $460 million. So we're talking about $750 million impact for Carnival for this kind of device, for this kind of application. So as I mentioned earlier, 57% of my customers said they saved more than half on their infrastructure when, after they deployed Couchbase Capella. Okay, so finally, creates a high degree of business value, and there we are. So, and look at that, I'm right on time. So thank you everyone. We're in booth 2445 down the road here. Come by, stop off and talk to me, anyone on my team, and I thank you for your attention today.